Math 1314, Tyler Junior College, section 2.4, more about slope. Perpendicular lines, part 1. Question, and you'll be surprised how many people get this wrong. What is the opposite of parallel? Well, naturally, it's perpendicular. You wrote that on the board, except that's not correct. There's this false misconception, which I believe is redundant. There's this misconception that the opposite of parallel is perpendicular. That is incorrect. And by the way, in case you forgot what perpendicular means means two lines that meet at a right angle, a perfect square 90-degree angle. But the opposite of parallel is not perpendicular, because I can draw lines that are neither. Those two lines are neither parallel nor perpendicular. What does parallel mean? Parallel means non-intersecting. So what's the opposite of parallel? Intersecting. Perpendicular is just a special case of non-parallel lines where the two lines form a 90-degree angle. So why do perpendicular lines get special mention as opposed to just non-intersecting lines in general? Because perpendicular lines have a special relationship between their slopes. Now, I could just tell you this is what it is, but that's no fun. So let's see if we can figure it out. On the board here, I have a generic red line drawn with a generic run and rise used to calculate the slope. Slope equals rise over run. That look a little bit better there. So my question is, what is the relationship between this slope and the perpendicular slope? Now, the symbol for perpendicular looks like an upside down capital T. So for example, if we said AB upside down capital T, CD, we're saying that there's two line segments that are perpendicular to each other. So since that's the symbol for perpendicular, it should stand to reason that I'm going to write the symbol for perpendicular slope as M subscripted with the perpendicular symbol. So, what's the relationship between the slope of the blue line and the slope of the red line? Well, one way to think about creating perpendicular lines is to take a given line and rotating it 90 degrees. Well, what would happen to this run and this rise if I dragged them along with the blue line and rotated them up here? Well, the run would be about here. I'm just kind of eyeballing this. So there's the run. And then the rise would, if I rotated it, point to the left. But I'm kind of reluctant to now label them rise and run, because look at the directions they now go. The run, before we rotated it, went to the right. After we rotated it, went up. So maybe I should put quotes around it to indicate that it's not really the run anymore, but it came from the original run. And the same thing for the rise. The rise before I rotated went up, but now the rise after I rotated is going to the left. So it's not really a rise anymore. It's a run, but I'll put quotes around it to indicate that it came from this rise over here. So there's issue number one. The rise and the run essentially switch places. So now, what used to be the run is on top, and what used to be the rise is on the bottom. Oh, so they're reciprocals. Well, not quite. Think about the red and the blue line in terms of positive and negative slopes. The way I have the red line drawn, the slope is positive because it's increasing. But the way I have the blue line drawn, it's decreasing. Remember, it's always left to right. And decreasing lines should have negative slopes. So if all I do is reciprocate this, I'll get a slope that has the incorrect sign. So the blue line should have a negative slope, but why? I'm going to go ahead and put a negative in front of it. But what's the justification for doing it besides the fact that the blue line is decreasing and the red line is increasing? Answer: one of these generic arrows changed in terms of signs. The way they're drawn here, the run is going to the right, so it's positive, and the rise is going up, so it's also positive. But when I rotate it 90 degrees, one of them switched from going in a positive direction to going in a negative direction. And it's the one that was originally the rise. Pointing up is in the positive direction, but upon rotating 90 degrees, it's now pointing to the left, pointing in the negative direction. But what if the line was the other way around? No matter how you draw the original, one of them will switch signs. So one may switch from positive to negative or negative to positive, and the other one stays the same. So that's the reason we pick up as negative, because one of our vectors, if you will, arrows if you won't, one of our arrows is now pointing in the opposite signed direction. In this case, it was the rise, which was positive, and then negative. So not only does the slope get reciprocated, it also picks up a negative sign. So it's the reciprocal, but the opposite of it. So that being said, perpendicular lines have opposite, meaning one is positive and one is negative. Reciprocal, meaning you turn one upside down to get the other. Slopes. So you have to do two things to get a perpendicular slope. So in this particular example, let's say that this slope was, we'll say it's 5/3. What would the slope of the blue line be? Well, to get the perpendicular slope, you both take the negative, or the opposite I should say, since the original slope was positive, its opposite is negative, and reciprocal. Since this was 5/3, its reciprocal is 3/5. And that's the relationship between perpendicular lines. So let's try find the equation of the problem real quick. For example, find the equation of the line. Sorry, I should have had this problem written before I started the video. That passes through. So we just need an ordered pair. We'll keep it kind of simple. We'll say 6, 7 and is perpendicular to, let's go ahead and get something in slope-intercept form. Let's say y equals 1/3 x plus 5/3. Okay? Oh, answer in slope-intercept form. Just to make this a short example. Okay? Remember, when you build the equation of a line, you almost always, not always, but almost always start with point-slope form. But in order to use point and slope, I need the correct slope. I already have a point. What is the slope of the original line? 1/3. Since the slope is 1/3, then what will the perpendicular slope be? Well, if I take its opposite, it's going to be negative. But if I take its reciprocal, it's 3/1. But 3/1 is better known as 3. So we're going to use a perpendicular slope of -3 along with point slope form. So for point slope form, y minus the given y coordinate, so y minus 7 equals the slope, -3, times parentheses x minus the given x coordinate, so x minus 6. This will be easy to get in slope-intercept form. So distribute the -3 to get -3x plus 18 on the right side, while the left side remains y minus 7. And then add 7 to both sides to isolate the y. And we get y equals -3x plus 25. So pretty easy finish because the slope ended up being an integer. Just for kicks and giggles, do you know what general form would be? To get general form, we need to make it equal to 0 and make sure the x is positive. And there are no fractions. That part's already taken care of. But for the other two, we can just move everything to the left. So the 3x would move and change signs, it'll become positive. The y is not moving, so it's not changing signs, so it's still positive. The 25 is moving, so it's changing signs, it becomes negative. The general form would be that. So perpendicular is not that difficult, you just have to remember that perpendicular lines have opposite reciprocal slopes.